Hello everyone. Today we are going to verify Stokes theorem for this F vector where S is the surface of the cube, okay, for this boundary lines. So first we have to draw the diagram for the given data. So as the given surface is a cube, so I have drawn a cube, right? So here we have to understand a lot so that we can proceed our sums, right? So first we need to draw the cube for this given data. Here x equal to 0, then y is equal to 0, so z is equal to 0. Similarly, x equal to 2, y is equal to 2, and z is equal to 2. It is the cube. So you have to draw a cube. So we know very well how to draw a cube, where we have to pick what is x-axis and what is y and what is z. So I have taken this line as x-axis, right? Let us come to here, this line as y-axis and this one is as z-axis. So here, the word above xy plane is very important because S is the surface, right? So S is the surface which is above the xy plane. Xy plane means this is x, y. It is a surface above the xy plane, which means they are mentioning only above the xy plane, which means above the xy plane have been closed, right? So this is the bottom surface which is not closed, okay, which is open. So this is open, bottom surface is open. The above surface are closed. Understand? This is what they are saying from the given data in the question, right? So after drawing the diagram, let us come to here. Here, what we are going to verify. Before that, we should know what is Stokes theorem. So this is the statement of Stokes theorem. So this is the statement of Stokes theorem. What is in this statement? The rotation speed in the boundary line, which is equal to the rotation speed in the surface area, which means if you want to find out the rotation speed, okay, for anything, you can calculate being in the boundary line, okay, that is equal to the rotation of surface line. So this is what is saying in the Stokes theorem. So let us prove this vector is satisfying Stokes theorem or not. Okay. So first, before I am going to prove, I need some information. So I need to know what is this 4 points. Okay, what is this 4 points? Because this is the bottom surface is open. So we are going to take these 4 lines as a boundary line. So we are going to calculate the rotation speed in the boundary line, and also we are going to verify this rotation speed is equal to this surface, the rotation in the surface, right? That we are going to verify. Understand that? Okay. For that we need these 4 points because these 4 points is going to give us the boundary line. So first, obviously this is origin. So origin line we know very well, it is 0, 0, 0. It means x0, y0, z0. Let us come to here. This is x-axis. Here we will have x equal to only 0 to 2 because it is given in the question. X equal to 0 to 2, right? So let us come to this point. This is y is equal to 0, 2 and 2. So y is equal to 0. This time y is equal to 0 to 2. Okay, other variables are 0. Other points are 0, sorry. Now let us come to fix this point. So this is the line from y-axis and this is the line from x-axis, right? So here we will have only xy point. Okay, z will be 0. So x equal to 2 and y is equal to 2, then z equal to 0 this time. Understand? So after plotting these 4 points, you have to name these 4 points. This is going to be O, this is A, this is B, this is C. Okay, OA, AB, BC, CO is the boundary line. Okay, the rotation speed in the boundary line is equal to the rotation speed in the surface area. That is what is saying in the Stokes theorem. Okay, let us come to verify. First, write what we have in the right hand side in this statement. So this is my right hand side. So I just have written what I have in the right hand side. So it is double integral del cross F vector n cap into ds, right? So first we need to calculate what is del cross F vector. What is del cross F vector, right? So we have a formula to calculate del cross F vector, which means to calculate your rotation, you have to use del cross F vector. Understand that? So the formula is First we have to write the vector component. It is I vector, j vector, k vector. Let us come to write the dou component in the second row. So it is dou by dou x, dou by dou by dou by dou z. Here, this is very important because most of the students are making mistake here. Okay, they don't know how to write this third component, right? Which is nothing but which is f component. Here f1, f2, then f3. You have to write what is f1, what is f2, and what is f3. Understand that? That can be taken from the capital F. That means your main f vector. Understand that? This is my f vector. From f vector, I'm going to pick what is f1, f2, f3, which is nothing but the coefficient of I vector is called here f1. Similarly, the coefficient of j vector is called here f2, and coefficient of k vector is called here f3. Okay, after identify what is f1, f2, f3, you have to write in the third row. Now you know very well how to take determinant. So by determinant rule, I am going to take determinant. So this I vector we have to write first. Now after that, we need to remove these intersecting row and column. Then the resultant part is these two. This time we have to take cross multiplication of these two, these four. Okay, when you take cross multiplication of from here to here, that means dou by dou by of then this function, right? So which means you have to differentiate this function with respect to y. Okay, so to differentiate with respect to y, we should have the y variable in this function, but there is no y variable. So if we do not have y variable, which means the other variables are constant. So when you differentiate constant, your answer is 0. Therefore 0. Let us come to bottom to top. So this time you have to differentiate this function. So which means this will be like dou by dou z of y z plus 4. I'm just writing for your understanding purpose here. Okay. So which means you have to differentiate this function with respect to z. Right. So this time we have z here. When you differentiate with respect to z, your answer is 1. Therefore the answer is 1. Here we don't have z, it is constant, the 0. So it is 1 into y, the answer is y. So when we are when we are multiplying, okay, cross multiplying from bottom to top, we have to add a minus. So therefore it is minus y. The same, okay, situation you have to follow for is j and k. Okay, when you write the second vector, you have to add a minus. This is rule. Now this time you have to remove this intersecting column and row. What is the resulting component? These four, right? This time these four. You have to take cross multiplication of these four. Understand? Okay. This time we need to here what we have to do, which means dou by dou x of minus x z. It means you have to differentiate your given function with respect to x. The answer is minus z. Similarly, from bottom to top, dou by dou z, it means you have to differentiate this function with respect to z. Understand? So we have z here, it is minus 1. So when we do multiplication of from bottom to top, you have to add a minus in formula. So the minus into minus, it is plus. Understand? Therefore plus 1. Let us come to the last component, it is k plus k. So it is plus, minus, plus. This is the rule in determinant. So now plus k. This time you have to remove this intersecting column and row. Understand? So what is the resulting factor? These four. This time you have to take cross multiplication of these four. So when you take cross multiplication of these two, this one will become dou by dou x of y z plus 4. Right? Understand that? So this time you have to differentiate this function with respect to x. When I look at inside the bracket, there is no x. Okay, so all the terms are constant. So the answer is 0. Therefore, it is 0. When you multiply this vector from bottom to top, you have to add a minus. Therefore, minus. Then this time you have to differentiate your given function with respect to y. So we have y here. The answer is 1. So therefore, minus 1. Understand? This is the way how to take determinant for the given given values. So after doing this, let us come to the simplification part. You have to simplify this. After simplification, you will get this one. Okay, this is my del cross F vector. Now I need del cross F vector I have got just now. Let us move to find what is n cap. Okay, to find n cap, we should know n cap is nothing but it is unit normal vector. So we have to find out the normal vector for this open surface. Always you will be given with some open space. Okay, for all the problems, that is your boundary. You are going to collect your boundary lines in your open surface, right? So you have to find out your normal vector for this open surface. Okay, normal vector is nothing but the perpendicular line to this open surface is your normal vector. So what is the perpendicular line? This is bottom. So this one is going to be top. So therefore, this line is going to be, or this line is going to be the perpendicular line to this surface, bottom surface, right? So this line is going to be the perpendicular line. So all these lines are called the normal vector. So I'm going to take this z axis. So when you take this line, it is going to be always z. So all the line is going to be in terms of z. So this z axis. So the vector to represent z axis is k. Okay. So all for this sum, the normal vector is k. Wherever you take any point, it is going to be k in terms of k, because all these lines are going to be z axis, right? So the vector to represent z axis is k, which means the k vector will be passing through the z axis. Understand? That is why n cap is going to be k vector. Okay. Also, we need to find out what is the ds. To find ds, okay, we have to get what is the integrating factor. So the integrating factor for z axis is going to be always dx dy. Suppose if you want to find out the integrating factor for y axis, okay, you have to write the other component, other axis, that is dx and dy. Sorry, dz. For x axis, that means for I vector, the integrating factor is dy and dz. So this is already we have studied, okay, in formula table. Okay. Now after writing all these information, so now we know what is n cap, ds, and del cross F vector. What is your next step? You have to substitute all these current result in your right hand side formula. So after substitute, before I am going to substitute, I want to get what is the del cross F vector dot n cap. So I know what is del cross F. This is my del cross F vector, and this is my n cap. I'm going to take dot product of these two. When I take dot product, so what will come? So you can multiply only k with the k. Okay, when you multiply k with I, k with j, the value will be 0, right? So what is the remaining? You will get only k dot k. So it is 1. So already we have minus 1. 1 into minus 1 is equal to minus 1, right? Therefore, the dot product of these two is minus 1. Now substitute all these. So del cross F vector dot n cap is minus 1. So I have given minus 1 here. Then I have written what is ds. So I know very well what is ds. So I have written here. Then as usual, double integration. It is very easy. You keep minus 1 in the outside. Now when you take x, your answer is 2. You keep outside. When you take with respect to y, when you integrate with respect to y, your answer is again 2 after substituting the limit. Therefore, 2 into 2 minus 2 is the minus 4. This is your rotation speed. That means when you are calculating your rotation speed in the right hand side, this is your answer. Let us check whether we are meeting the same answer in the boundary lines or not. Okay. So let us come to right. That is the left hand side. What we have in the left hand side in our statement? It is f vector dot dr vector. We just write f vector dot dr vector. So which means the closed curve. This is the closed boundary curve. Okay. So this common C can be separated into 4 lines. That means these 4 lines are called the closed curve, right? So that is my boundary line. So I have separated this curve into OA. So this is OA, then plus AB, then plus BC plus CO. So I have written these 4 curves here. Which means I'm going to calculate what is f vector dot dr vector in each line individually. Okay, at the end I'm going to add all these results. That is my final answer. Okay, now before I'm going to find out all these information alone, so I want to know what is the f vector dot dr vector, because I need this for all the lines, right? So we know what is f vector, which can be picked from our question. So f vector, I have written the f vector. Dr vector is nothing but, so I let you know how to write the dr vector. It is very easy. If in your f vector, this is my f vector, right? So in my f vector, if I have I vector, j vector, k vector, then you have to write dx I vector plus dy j vector plus dz k vector, right? Suppose in your f vector, if you have only I vector and j vector, then you have to stop from here, right? So because you have to write dx I vector plus dy j vector. Suppose if we have only I, then your dr vector is nothing but dx I vector. Understand that? This is the way to write the dr vector. Okay, after writing all this, then you have to take dot product again. So already it's been clearly explained how to take dot product. That means you have to take the dot product only I with I and j with j, then k with k. So other component will be 0. So when I take I with I, the answer is 1. Therefore, the remaining element is this one and this one. So that is written here. Then plus the second part j with j, these two. So 1, the answer is this one. Similarly for k, right? So now this is my f vector dot dr vector. Let us come to here. So along OA, now I'm going to find out the rotation speed, right? So to calculate along OA the rotation speed, I need some information. So I'm going to get in the boundary line. So let us come to here. So along OA, I want to know x varies from which point to which point and y varies from which point to which point. Similarly for z. So here x, y, z, right? So x varies from 0 to 2. Okay. Y varies from 0 to 0. Z varies from 0 to 0. So that is I have written here. X varies from 0 to 2. Y varies from 0 to 0. You can write as simply 0. Similarly for z. If y is 0, then what about dy? That also 0. If z is 0, similarly dz is also 0. Now what you have to do, this is your current result, right? So you have to substitute this current result in your along OA. Now let us come to here, along OA, f vector dot dr vector. So this is my f vector dot dr vector. So instead of writing this f vector dot dr vector, I can directly write this one. So in my f vector dr vector, I have to substitute all these results. So what is my results? Y is 0 and dy is 0. So this time completely this y part will be 0, right? This y part dy 0 now, this entire value will be 0. Similarly dz 0 means this entire value will be 0. Let us come to y 0 z 0. In first term y z is also 0. So we have only 2, right? So 2 into dx. It means you have to write dx here. So you have to write only x limit. X varies from 0 to 2. Understand? X varies from 0 to 2. That's all. Now normal integration, your answer is 4. Okay. Let's come to along AB. The same thing you have to find out. So in AB, what is x varies from? This time x varies from 2 to 2 and y varies from 0 to 2. Z varies from 0 to 0. Let us write all these results. X varies from 2 to 2 can be written as simply 2. Y varies from 0 to 2 can be written as 0 to 2. Similarly Z. Now find out x equal to 2 means it is constant. If x equal to 2, then dx is also 0. If z is equal to 0, then d is the information for all, right? So now this time you have to substitute this results in your f vector dot dr vector. This time along AB, f vector dot dr vector. What is the result? This time dz 0, so this part 0. This time dx 0, so this part is also 0. And we have only this part. In this part also we have z 0, right? So when you take y into z, it will be 0. We will have only 4 into dy. So therefore 4 into dy. It means we have to write y limit. Y varies from what? 0 to 2. After simplification, your answer is 8. Let's come to BC. So in BC, we have to pick what is x, y, z value. X value is from 2 to 0, y value is from 2 to 2, z value is from 0 to 0. So write all these information and get some other results, substitute that, then find out your answer is minus 8. Similarly for CO. So from CO, this is my C and this is my O. I have to pick what is x. X equal to 0, y is equal to 2 to 0, z is equal to 0. Okay. So now from this, dx 0, then dy dz is also 0. Now substitute all these results in f vector dot dr vector. After substituting, your current result is only 4 into dy. So after simplifying this 4 into dy, your answer is minus 8. Now what we have to do? I need to know what is the closed region. So for that I have to add all these 4 lines. So in first line I got 4. In second line I got 8. In third line I got minus 8. Similarly, in fourth line I got minus 8. Okay. Now these two will be cancelled. The answer is minus 4. This is what we have to meet, right? So in right hand side we had minus 4. Left hand side also we have minus 4. Therefore, right hand side is equal to left hand side. Hence verified Stokes theorem. Okay. I will meet you in next sum. Thank you.